This video will deal with double displacement reactions. Again, your goal is when given the reactants, you will be able to determine what type of reaction it is and be able to predict what will happen. Double displacement reactions of all the reaction types we have done and will do has the most other things that you need to know and do with the reaction type, so just be aware of that. This video will also talk about the solubility of ionic compounds because that's a component that's needed when you're predicting products for double displacement reaction. Okay. So what is a double displacement reaction? Well, the single replacement reaction was when one element kicked out another element, right, and replaced it in a compound. Now for double displacement, instead of having one single element and one compound reacting, we have two compounds reacting. So double displacement simply means we have this replacement happening, and basically we're making two new compounds rather than just one new compound. Okay. So for example here with these two pictures, basically these two guys switch something about themselves. In this case they switch hats. Okay. So it's two compounds reacting, and if you look at the chemical reaction, you know, it always goes metal bonded to a non-metal in one compound, and then metal bonded to another nonmetal in the second compound. Over the course of the chemical reaction, what happens is they just change partners. Okay, so a metal replaces the metal within the compound, or you can look at it like the nonmetal is replacing the nonmetal. But either way, within the two compounds that are being produced, the partners are being switched. So here is an example of this happening. You can see that aluminum is bonded to chlorine and sodium is bonded to the phosphate. And then as the chemical reaction proceeds, aluminum changes partners to be bonded with the phosphate, and sodium changes partners to be bonded with the chlorine. I have another example double displacement reaction back here. Sodium with chlorine, lead with nitrate. The easiest way to predict products for these is to add your arrow and then to rewrite the chemical equation product component with one set of elements in the same spot. So for example, when I do it, I always leave the metals where they are. So you're going to have sodium and you're going to have lead still. And then you're just going to change their partners so that you don't do too many changes. So sodium is going to be bonded with the nitrate now. And sodium's +1 and nitrate's -1, so that is completed. And now lead is going to bond with the chlorine. I can tell that lead is +2 based on up here, the fact that lead had to be a +2 to balance with the nitrate's -1 crisscross. That's where this 2 came from. So since lead's +1 and chlorine's always -1, crisscross, there is my final compound that has been produced when sodium chloride reacts with lead nitrate. Now, of course, you always have to go back through and actually balance your chemical equation in relation to the conservation of mass, okay, which shows me I need a 2 here and a 2 here. But that's what a double displacement reaction looks like. So keep one component in the same place, like your metals, and just flip your nonmetals. Rebalance their charges, add your coefficients, and your double displacement reaction is complete. Now again, you'll know these reactions, that this is that reaction type on the fact that you have two compounds reacting. If you had one element in a compound, then it would be a single, but two compounds means it's a double. Now a couple things. Once we got into single displacement reactions, there were actual rules for whether the reaction would happen or not. It gets more complicated with double displacement reactions too. So if you look at the situation, we have two ionic compounds that are switching their partners. Okay. And we've seen in the lab, and I'll show this to you guys in class also, that ionic compounds usually are white crystals, right? They're solids at room temp. If you mix two solids together, it's very boring. Nothing happens. So to get two ionic compounds to chemically react, these reactions are generally done in water. Okay? So usually your compounds are aqueous compounds. If you put two aqueous compounds together, the chemical reaction that you're going to be seeing, the chemical change that will occur, is the formation of a precipitate. So what we're looking for in a double displacement reaction are those precipitates, are those solids. So one thing you need to be able to determine within a double displacement reaction is whether an ionic compound is soluble or not. When we first learned about ionic compounds, we learned that ionic compounds are soluble. Okay, they're charged, which means when you put them in water, they will dissociate. The truth is, all ionic compounds are partially soluble, but not all of them are very soluble. Some of them are only soluble to a very small extent, so we call them insoluble. And the reason they're insoluble usually is the fact that water can't dissociate the ions. For some reason, they're either very tightly bound, or sometimes it's that they're very big, and water can't dissociate the ions. So then they stay together as a compound in water and don't dissolve. Okay. So something you need to be able to determine how a double displacement reaction will actually proceed, is determine whether the ionic compounds that you're predicting are solids in solution or are dissolved in solution. Okay, whether they're precipitates or whether they're soluble. What you have to help you with this is on the back of your periodic table. You have a chart in the back of your periodic table called labeled double displacement, and it says solubility rules in water. So we'll spend more time in class actually looking at this, but I do want to overview it for you. If you look at this table, what you're going to see are all the negative ions. Okay, it's organized by anions. On the left-hand side, you have all of the anions that we're generally going to encounter in ionic compounds. The top of this table says they are soluble ionic compounds. So ionic compounds created with those anions as the anion in the compound, they will be soluble in water. Okay. The bottom anions now, the ones at the bottom of this table, are the ones that are insoluble. So generally speaking, when you have those anions bonded to a cation, they will be solids in solution. They'll be precipitates. Now we have a second column as part of this table where it says important exceptions. And the way the important exceptions work depends on which part of the table you're looking at. Okay, up top, up on this top portion right up here, if you have any of these anions, generally they're soluble, meaning they will be aqueous in water, unless you have an important exception bonded to the anion. So for example, if you have silver bonded with chlorine, or mercury bonded with chlorine, or lead bonded with chlorine, only in those three cases is it an important exception, in that chlorine is usually a soluble component, but if it's bonded to one of these other metals, it will be insoluble. These will make solids in solutions. They will be precipitates. The bottom of the table works the same way. These anions are generally insoluble, but if these anions are bonded with any of the metals in group 1 or some of these other exceptions, they will actually become soluble rather than insoluble. So let's apply this table to this chemical reaction I have behind me. Sodium chloride, you should already know if you put sodium chloride in water what happens. Okay, it dissolves, and if you look at your table, you can verify that. Chlorine is a soluble ionic compound, okay, which means it would dissolve, and sodium is not one of the important exceptions. So chlorine dissolves in water, sodium chloride will dissolve in water. This is an aqueous ionic compound. Lead nitrate, if we look at nitrate, which is up on top, NO3, it is also soluble. There are no important exceptions, so every nitrate is soluble in water. So I just said every nitrate is soluble in water, so that means sodium nitrate is also soluble in water. And if we check our chlorine, we already said chlorine was soluble, but take a look, lead is one of the important exceptions. And because lead is an important exception, while chlorine is normally soluble, if lead is bonded to the chlorine, it is insoluble, and that is your solid in solution. this is what you can depend on happening for a double displacement reaction. You should have two aqueous compounds reacting to begin with, because remember, two powders do nothing, so you're going to be in solution. And overall, in order for you to see a result, you have to have a solid form. Because if you put two aqueous solutions together and all you made were two more aqueous solutions, there wouldn't be a sign of a chemical change. The only way to see a double displacement reaction have a result is for it to form an insoluble product. In class, we'll go through how to predict these states of matter more articulately, but you should be able to predict products by keeping the metals where they are and flipping their nonmetals, re-neutralizing the charges, and then overall balancing the chemical equation. Have a nice night.